Hello and welcome back to PrepMate Online Classroom. Today we are going to be discussing a topic which is very important in geometry, which is polygons. So polygons are closed shapes that are formed by straight lines. Here are some examples of polygons, like we have triangles, we have quadrilaterals which have 4 sides, and we have pentagons that will have 5 sides like this, and we have hexagons and so on. So we have 2 types of polygons for our discussion today: the regular polygons and the irregular polygons. In irregular polygons, all sides have equal lengths and all angles have equal measurements. In other words, they are equilateral. Okay, they all have the same side, same measurement for each side, and also they are equiangles. They have the same angles. So for example, a regular 3-sided polygon, as we know, is an equilateral triangle. A regular 4-sided polygon is obviously a square, all of us know. And a regular 5-sided polygon is a regular pentagon, and so on. Irregular polygon may have sides with different lengths, like for example in this case a triangle with different lengths and different measurement of angles and so on and so forth. And the same way a quadrilateral, pentagon, and so on. So the most important the difference that we would have to note is that regular polygon is something where all sides will have the same equal measurement and all angles will also have the same equal measurement. In an irregular polygon, it doesn't have to be like that. Now, having said this, so today's topic is going to be to discuss the interior and exterior angles of polygons. So let's try to first of all understand the terms interior angle and exterior angle. An interior angle is formed within the shape by 2 sides, 2 adjacent sides. Like for example in this case, or in this case like this is an interior angle. So you have interior angle in both the irregular polygons as well as the regular polygons. Okay. Now, for us to understand what exactly is an exterior angle, we need to extend any one side of any polygon like this. If you extend the side like this, then what the angle that is formed is known as the exterior angle. For example, let's take this shape, the pentagon. So you can just probably take any side and extend. You will get the exterior angle like this. For example, you get exterior angle. And the same case here with regular polygons. Okay, and the most important property of a polygon angle that we are going to learn today, and we got to remember, is that for any polygon, like whether it's a 3-sided, 4-sided, 10-sided, the sum of all exterior angles will always be 360 degrees. So for example, let's take this case. So if you extend the angle like this, 1 and 2, and then there are 3 exterior angles. So I'm going to call them as A, B, and C. So A plus B plus C will be 360 degrees always. Let's take another shape. Let's take this shape. This is a regular pentagon. So I'm going to extend the all the sides like this to create exterior angles. So let's call this as, let's say, A, B, C, D, E, and therefore the sum of all the exterior angles, A plus B plus C plus D plus E, will be equal to 360 degrees. That's also true for even irregular polygons. Like for example, let's extend this way. That's fine. Should extend the same way. So if we extend this, let's call this as A, B, C, and D. And so again, A plus B plus C plus D will be 360 degrees. Did you get that? That's pretty cool. This, if you remember this very well, then you can solve all problems of polygons without remembering a lot of formulas. Okay. Now, in the case of the interior angles of a polygon, again, the sum of the angles of these polygons of the same type of polygon, the sum of the interior angle of the same type of polygon will always be same. What does that mean? Let's create some space here, okay, by erasing all these text. Come on, go away. I managed to make some space. Now, if you take, let's take the case of a triangle, okay, which is a three-sided polygon, okay. Whatever is going to be the shape of the triangle, okay, the sum of the interior angles of any triangle is 180 degrees. We know that, right? 180 degrees, no matter whether it's equilateral triangle or isosceles triangle and so on. The same case, for example, if you take a pentagon, okay, if you add the sum of the interior angles of the triangle of this pentagon, it will be the same, which in this case is going to be 540 degrees. I'm going to explain to you how we get the 540 degrees, okay? And the same thing applies to a quadrilateral. For example, if you take this quadrilateral, if you add the sum of the interior angles of this quadrilateral, it's going to be 360 degrees. We know that, right? And the same case, if the quadrilateral is going to be like this, if you add this, if you add all the interior angles, the measurement of all interior angles, that will be again 360 degrees. And so for a given shape, it's a five-sided shape, for example, a pentagon, whether it's regular, irregular, or whatever is going to be the size shape, the sum of the interior angles will always be 540. Okay. And so how are we going to find out this without remembering a formula? For example, we have a formula like this. The sum of the interior angles of a polygon is n minus 2 times 180. For example, let's take the pentagon. Okay, I'm going to use the formula. N represents the number of sides. So there are 5 sides in this case. So therefore, the sum of the interior angles will be 5 minus 2 multiplied by 180. So 5 minus 2 is going to be 3 times 180 is going to be 540. Fine. But I always suggest that let's try to find a way to come up with this value very quickly instead of remembering the formula. So the method that I'm going to teach once again is going to be very simple and very intuitive. You can remember that very, very easily and without just having to memorize all these formulas. Okay, so let's take this polygon. Let's take this pentagon. So I can split the pentagon like this into triangles. Here is one triangle, here is another triangle, here is a third triangle, as you can see. Okay, so there are 3 triangles, and so 3 triangles times 180 each triangles measures 180 the sum of interior angles. That's going to be 540. Is that cool? Okay. And the same case, for example, let's take this is how many sides? 1, 2, 3, 4, 5, 6 sides, which is called a hexagon, as you probably know. So you can split them into triangles like this. So there are 1, 2, 3, and 4 triangles, and so therefore 4 times 180 is going to be 720. So like in the previous lesson, in one of the lessons, we discussed open parenthesis. How did we know that 4 times 18 is 72? That's pretty simple. And this is how you become, very skilled in math, like for example, this can be split as 4 times 10 in your head, which is going to be 40, and then 4 times 8 again in your head, which is going to be 32. That's going to be 40 plus 32 is 72. So over a period of time, if you keep practicing this, you instantly know that 4 times 18 is 72. Okay. Now let's take this case. So this is also a hexagon, but irregular. Like there are 6 sides, as you can see, and you could have the same way you could have just split that into triangles, and there are like 4 triangles times 18. So which would mean that this, whatever I'm teaching right now, will apply to any polygon, where all that we have to do will be to split the polygon into small triangles inside the shape, and multiply each one of them by 180 to find out the sum of the interior angles of a polygon. But as you practice, we can also, to minimize the time, we know that the sum of the interior angles of a triangle is 180, and the sum of the interior angles of a quadrilateral is 360, and therefore we can split a shape into not necessarily just into triangles, but triangles and quadrilaterals. Like for example, in this case, you can split this into a triangle, again a quadrilateral, and another triangle. So this is going to be 180, this is 180, this is going to be 360, and so when you add up this, you get 720. Did you get that? That's very easy, right? So as we go, I would teach you. So there are 2 things that we learned here. 1, the sum of all exterior angles of any polygon, whether it's triangle or a quadrilateral or a pentagon, is always 360. It's like the super number that you would like to remember. Okay, and the sum of the interior angles of the same type of polygon is always n minus 2 times 180. That means that they all have a constant value. For example, like a triangle, the sum of the interior angles is 180. For a quadrilateral, it's 360, and for a pentagon, it's 540. And then if you forgot how exactly we went through that, please rewind the video, and then you would know how we split the shape into triangles and quadrilaterals, and then just add up to find out what is the sum of the interior angles. Did you get that? Cool, very good. So like I said, one of the good things about participating in an online classroom like this is your ability, or the comfort of just going back and rewinding the lesson, and then take the lesson as many times as you like. Not necessarily like just today, but like after like 10 days you forgot how exactly this works. Come back and take the same lesson one more time. All right, so let's move on with our life. Let's see what happens next. Okay, so we just learned how to find the measurement of the interior and exterior angles of polygons, but let's try to have some more understanding how exactly this works. Okay, and we are now going to be limiting ourselves to talk about the regular polygons. Okay, let's take a triangle. So like what I said, if you extend the sides of the triangle, you create 3 exterior angles, and we know that the sum of these 3 exterior angles will always be 360. And because this is a regular polygon, all of this, each of this, the exterior angle will have the same measurement. Therefore, each of them will measure divided by 3, which will be 120 degrees, like this. Okay. Same way, like for example, if you take a regular 4-sided polygon, a regular quadrilateral, which will be a square because all the 4 sides will measure the same, and if you extend the the sides, then you know that you create an exterior angle which will always measure 90, as we know. Okay, in this case like this, so 90, and so 4 times 90 is going to be 360. So let's now take a regular pentagon where all the 5 sides measure the same, so let's create the exterior angles by extending the sides like this. And so as we know, there are 5 exterior angles, and so the sum of all the exterior angles, as we learned, is going to be 360. So each one of the angles will measure 360 divided by 5, and that is going to be 7 5s are 35, and then 1 0 72 degrees. Each of them will measure 72 degrees. So this is true for a regular pentagon of any size. And so now let's take a closer look at this part where we have one of the sides like this, and then the second side is going away like this. And so our exterior angle, now we know, measures 72 degrees. And so the interior angle will be the supplementary value of 72, which will be 180 minus 72, which will be 108. Isn't that cool? Okay. Now, you could have got this, so which would mean that you can find the measurement of interior angle of any polygon just by remembering that the sum of all exterior angle measures 360 degrees. But you can also do the same thing by this formula, n minus 2 times 180. It will give you the sum of all the interior angles of a polygon. Like, for example, let's take the pentagon. Okay, in a pentagon there are 5 sides, and so the sum of the interior angles are going to be 5 minus 2 times 180, which is going to be 540. So if you divide 540 by there are 5 internal angles like this. So if you divide that by 5, you would know that each one of the interior angle will measure 108. And so there are 2 ways of finding this. The easier way is that remember that the sum of all exterior angles measure 360, and then you can find the measure of each exterior angle. This we are talking about is regular polygons. This will not apply to irregular polygons. Okay, so let's do this one more time. Let's try to find out the measurement of each one of the interior angles of a hexagon, and also the sum of all the interior angles of a hexagon. So as we know, there are 6 exterior angles in a hexagon, and the sum of all the 6 of them should be 360, and if we divide this by 6, that's going to be 60. So each of the exterior angle will measure 60, and each interior angle will measure the supplementary value of 60, which is going to be 180 minus 60, that's going to be 120. So there are 6 such angles are there. So 6 times 120 is 720. You could have also found out this by splitting this hexagon into, like for example, two quadrilaterals like this, and then each one of them will measure 360. So that should be okay. Would you want to try this for this shape? Let's try to find out how many sides are there. 1, 2, 3, 4, 5, 6, 7, 8. So 8-sided regular polygon is called octagon, correct? Okay. So take a moment, pause the video, and try to answer these 2 questions. What is the measurement of each exterior angle? And what is the measurement of each interior angle? Pause the video, do it yourself, and then resume. Play the video one more time, and then see if you are going to get it right. Now let me do this. Okay. So as we know, there are 8 exterior angles, and so the sum of all the exterior angles is 360, and when you divide this by 8, so what are you going to get? So 4 8s are 32, so the carry is how much? 20 and 5 8. What did I do? I'm sorry. One more time. So 360 divided by 8, 4 8s are 32, 4 40, 5 8s are 40, that'll be 45. Cool. And therefore each of the exterior angle measures 45, and so the interior angle will measure 180 minus 45, that is going to be 135. And to find the sum of all interior angles, I'm going to split them into 3 quadrilaterals. So that'll be 3 times 360, that's going to be 1080. Did you get that? Okay. So for you to understand this fully, I suggest that you pause the video, rewind the video, and try to go through the video one more time. Okay. And now let's move on with the next part of this lesson. We'll try to understand another concept about another property of the regular polygons. Regular or even irregular polygons. Just like the way you have diagonals in a quadrilateral like this, there are 2 diagonals, okay? And you also have diagonals for all other shapes like this. So for example, let's begin with a square, which is a 4-sided regular polygon, and so we have 2 diagonals like this. So a diagonal is nothing but a line, a straight line that connects one, what do you want to call that, edge to the other edge, other possible edge, except that it cannot be a side like this. And let's take the pentagon. So we have from, let's say I'm going to begin with this edge, and so you have 1 diagonal here, 2 diagonals here, and you also have 1 more diagonal here, 3 and 4, and then here 5. There are 5 diagonals. Okay, let's take the hexagon. So you can draw diagonals like this and go to the next edge and draw more diagonals like this, and so on. You see that? So therefore there are, as the shape becomes more multi-sided, there are going to be more diagonals. So there's a way by which you can find out what is the total number of diagonals for a given polygon. As long as the polygon is not too many sided, you can just draw and figure out. But you can also use this formula, which is not very difficult to remember. But before we go to this formula, let's take a look at the triangle, the 3-sided polygon. Are there any diagonals? Nope, because every edge is connected to the other edge as a side. So there is no way by which you can have a diagonal. Therefore, the number of diagonals are 0. If you remember this, then you would see that in this case, the number of diagonals is equal to n times, n is the number of sides, n minus 3. So in a triangle, 3 minus 3 will become a 0. So everything will become 0. So number of diagonals will become a 0. That's one way by which you can easily remember this formula. So now applying this formula to, let's say, a quadrilateral, okay, it's going to be 4 times 4 minus 3, everything divided by 2. So that's going to be like saying 4 times 1 divided by 2, and then this goes away, that'll be 2. You see that? Okay. And so let's take the case of a pentagon. So it'll be 5 sides. So it'll be like saying 5 times 5 minus 3 divided by 2. That's like saying 5 times 2 divided by 2, and then 2 and 2 will go away, leaving us with the number of diagonals as 5 diagonals. That's exactly what we saw. Did you understand that? So, so we have learned about three important properties. We understood what exactly is an interior angle of a polygon, exterior angle of a polygon, and then the diagonal of a polygon. And we also found out how to find out, how to evaluate, calculate the measurement of the interior and exterior angles in a regular polygon, and then also the number of diagonals in a given polygon. Okay, let's move on. So it's time for us to take some questions. There's going to be a number of questions in this lesson. So you can now pause the video, read the question, try to do the question yourself, and then resume the video. So I'm going to read the question. So as before, what is the sum of interior angles of a nonagon? Nonagon is the nyagon. So note the spelling. It's not nanogon, it's nanagon. Okay, and that's nyagon. There are therefore the sum of the interior angles of a nanagon is that what we have got to figure out. There are two ways of doing this. If you remember the formula. Okay. I'm going to show you all three various different ways of solving this problem. First thing is, let's go by the formula. The sum of the interior angles, we are looking for interior angles, which will be is equal to n minus 2 times 180, if you remember this. And therefore, that's going to be 9 minus 2 times 180, which is going to be 7 times 180. So as before, we can do this as 7 times 10, which is 70, or 7 times 8, which is 56. So that's going to be 1260. Cool. Okay. So the answer is 1260. What are the other ways of doing this? Here is the second way of doing this. We know that a 9-sided polygon will have 9 exterior angles. And we also know that the sum of all the exterior angles is 360. And so when you divide this by 9, each of the exterior angle will measure 40 degrees. Cool. Therefore, each of the interior angle is going to measure 180 minus 40 degrees, which is going to be 140 degrees. Do you see that? So there are 9 interior angles. Therefore, 9 times 140 is going to be 1260. Did you understand that? You can also do that. The desperate way of doing this. The desperate way of doing this is that when you don't remember the formula, when you forget that, well, the sum of the exterior angles, add up to 360, then you start drawing like this. Let me create some more space. Okay, so we got to just draw a 9-sided shape like this. Just keep count of this: 1, 2, 3, 4, 5, 6, 7, 8, and 9. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9-sided. Okay, so then you just split them into like quadrilateral in this case, and then you also create one triangle. So therefore, this is 360, this is 360, this is 360, this is 180. So 3 360s are 1080 plus another 180. So that's going to be 1260. Did you get it? Very cool. In whichever way you do that, it's fine. You're gaining an understanding of how polygons they work. And so once you get comfortable, try to remember the formula. Try to remember that the sum of the exterior angles add up to 360 always. Okay, which is the easiest way. Let's go to the next question. Question number 2. Define the polygon in the diagram. Come on, this is the easiest question, right? Well, first thing is, let's count the number of sides. 1, 2, 3, 4, 5, 6, 7-sided polygon. So 7-sided polygons are called septagon or heptagon, okay? So therefore, we know that this is not a hexagon, this is not an octagon. Okay, the question is now, is this a regular septagon or an irregular septagon? Obviously, it doesn't look as if the sides, they measure the same. So I'm going to take this away and say the correct answer is it's an irregular septagon because the sides and the angles, they are different for each side and each angle. Question number 3. What is the measurement of one angle in a regular 3-sided polygon? Give me a break. So I'm going to draw a regular 3-sided polygon, which would mean that all the 3 sides, they measure the same. And what is this called? An equilateral triangle. Okay. So we know that they should measure 60. Come on, we don't have to spend time on this. Okay. So let's move on to the next question. Question number 5. The diagonals of a regular octagon intersect at O. This is a regular octagon, 8 sides, and they intersect at O. Find the measurement of the central angle. You know, if any diagonals, they make an angle at the center, it's called the central angle. Therefore, we need to find out what is this. Do you have any clue? Why don't you just pause the video, put on your thinking hat, and see how you can solve this problem. It doesn't matter how long it's going to take. Take like a couple of minutes or take 3 minutes. Take a piece of paper and start writing things. And draw the shape on your notebook and see if you can solve the problem. And once you are done with this, whether you get the whether you know or whether you did not understand. If you did not understand, I suggest that you go back to the beginning of the video, play, and so you can understand a lot of things. Come back here. Okay, so do you have an answer? Let's see. This is one of the easiest thing. There's nothing to do with the interior angles or the exterior angles. We know that the measurement of an angle around a point is always what? 360 degrees. Wow. And so this is an octagon, so there are 8 such angles here. And so each one of the central angles should measure 360 divided by 8. Now you notice that I always write the division like this instead of 360 divided by 8, because if you write a division in the form of a fraction, you can simplify it. Just like, for example, if you say 15, let's say you want to divide 25, has to be divided by 15. So if you do, let's say something like this, 25, and then you write 15, then you only have to just divide. That's it. But if, on the other hand, if you write 25 divided by 15, you can simplify. You can see that this is 5 5s and then this is 3 5s. So it becomes 5 by 3. So you simplify to have very happy life. So I'm going to simplify here. So therefore, 8 divides 360, like this is 1 8, and how many 8s are here? So there are 4 8s are 42, and the carry is 4 0 40, which will be 5 8s, and therefore each of the angles should measure 45 degrees. That's the correct answer. Did you get it? Did you go about finding this? All right, that's fine, okay, because you're talking about interior and exterior angles, and so you would be tempted to solve the problem in a different way, but always try to see what do I need to solve to find out the measurement of a given angle. So we are going to be discussing how to find out angles in another class one of these days, okay? So we'll move on to the next question, which is question number 6, as you can see here. So question 6 is, if the exterior angle of a regular polygon measures 72 degrees. So that means that there is some kind of a polygon and the exterior angle, you extend one side, measures 72 degrees. What type of polygon will that be? Well, you can use the formula. For example, we are talking about the exterior angle. So it's like the number of exterior angle is n. So 360 divided by n has to be 72. Do you agree with that? Therefore, n should be equal to 360 divided by 72, which is 5. Which would mean that the shape that you're talking about is a regular pentagon, 5-sided. For some of the common shapes for your grade level, it's important for us to know the interior and exterior angles of a triangle, of a regular triangle, regular quadrilateral, which is square, regular pentagon, regular hexagon. At least these 4 shapes. If you remember that, that'll be fine. That'll save a lot of time, because in a test, the critical thing is how we can save time. So avoid the urge to take your pencil and start writing like 100 different steps and so on. That's not what is expected in a test, right? So in a test, you should be able to solve these problems in typically like in under 60 seconds. Let's move on to the next question. Question number 7. How many diagonals does a hexagon have? Can you guys try to solve this by yourself? Okay, you can just go back and you can recollect what we did before, or you can do them by yourself. So let me do this. So one is the number of diagonals is always n times n minus 3 divided by 2. And so we are talking about a hexagon, which is 6 sides. Therefore, D is going to be 6 times 6 minus 3. And look at the parenthesis around this expression, 6 minus 3, which eventually in algebra we are going to be discussing this, some of the properties where this is, if you are going to have 2 different variables, we will be talking this as what? A binomial, correct? And divided by 2. So therefore that's going to be 6 times 3, everything divided by 2. For heaven's sake, don't multiply 6 times 3 is 18 and then try to divide. Simplify 1, 2 and then 3 2's. Therefore the answer is 3 times 3 is 9. Correct answer is 3. Did you understand that? Are you following the lesson? Very beautiful. So we have a few more questions to go. Let's go to the next question. Now, these are some of the questions that show up in a lot of tests. Question number 8. The measurements of interior angles of a hexagon, again, are shown in the diagram. Solve for x this time. We are solving for x. Now remember, we are not trying to figure out what is the measurement of an angle. We are trying to find out what is the value of this variable called x. Okay. So now this is a 5-sided shape, 1, 2, 3, 4, 5. So therefore, we know that we should remember that the sum of the interior angles of a pentagon is how much? Okay, very simple. Split that. This is 360, this is 180, therefore it's going to be 540. Do you agree with that? So therefore, all these values add up to, if you add them, you should get 540. Therefore, I'm going to write beginning from, let's say, here. Okay, x minus 18 plus x plus 25 plus x plus 15 plus x minus 12 plus 122 should equal to 540. Do you understand that? Very simple. Now combine the like terms. There are 1, 2, 3, 4, 4x. Okay. And then don't try to add them randomly. You can see that in many of the many of the numbers that you get in the test, they are very easy to combine or dissolve. Okay, so you have a 25 and you have a positive 25, positive 25, that's going to be positive 40. And negative 18 and negative 12, they make it how much? That'll be negative 30. So just for the sake of understanding, I'm going to write this as plus 40 minus 30. And then we also have a 122. Don't lose that, okay? 540. So this becomes 4x. So 40 minus 30 is 10. Therefore, add this to 122. That becomes 132 is equal to 540. So I'm writing a few steps, but you really don't have to do that because you need to save time in the test. And therefore, 4x is going to be 540 minus 132. You subtract 132 from both sides. You know, when we do algebra, I'm going to teach you some nice techniques of how to solve equations so efficiently, effortlessly. You will love that, okay? So coming back to this, so that is going to be 4x should be equal to 540 minus 100 should be 440, and take away 32, that's be 408. So x is going to be 408 divided by 4. That is going to be 102. Cool. So the correct answer is 102. Did you understand that? Did you get it? All right, let's move on with our life. And so I'm going to create some more space here for the next question. So the next question is this. Question number 9. Measurements of 5 interior angles of a hexagon have been shown in the diagram, not to scale, okay? And find x. Where is x? X is right here, okay? So x, as we can see, is what is the name of this angle? It's called exterior angle. Very cool. So now to find the value of this exterior angle, so we should ask this question, what if I know this, I would know x. So which would be this? Because let's call this as, let's say, y. X and y, they make the supplementary angles adding up to 180 degrees. Okay, and therefore, to find out y, we need to find out the sum of all the interior angles. And so this is what? This is a hexagon. So 1, 2, 3, 4, 5, 6. Yes, hexagon. So to find out the, let's say that we don't remember what's the sum of the interior angles of an hexagon. So I'm going to split this into 2 quadrilateral. That'll be 360 plus 360. That'll be 720. So which would mean all these values plus y should be 720. I'm going to teach you a nice strategy, a technique by which you avoid doing 2 computations. First thing, we need to add all of them, right? So write down like this, 109. I mean, if you cannot do that in your head, and then I'm going to go clockwise. So 107, and then 131, and then 105, and then 102. I should have started here, right? 102. And then this value, y, they should add up to 720. Now look what I'm going to do. Very often we would have to add up a bunch of numbers like this, and then subtract from a number like this. And this we usually do it in 2 steps, right? We add up, get a total, and then subtract. Now it's going to take time, and then we may make mistakes in a test. Every second is very precious for us. And so I'm going to teach you a technique by which you can do this in 1 step. This is how we do that. So we are just going to add up the numbers normally, just like the way you usually add. Like, for example, 9 plus 7 is 16, plus 1, 17, plus 5, 22 plus 2 is 24. We have 24 here. And then 24, take the last digit, 4. 4 plus what number is going to produce a 0. 4 plus 6 will be a 0. So we have a 6 here. So it'll be 24 plus 6 is going to be 30. So we have a 0 here, and the 3 becomes a carry. And you continue to add. 3 plus 3 is 6. 6 plus what number will produce a 2? 6 plus 6 will produce 2. So 6 plus 6 is 12. And so 1 will become a carry. 1 plus 2, 3, 4, 5, 6. So we have 6. 6 plus what number will produce a 7? 1. So the answer will be 166. In other words, if you add up all these numbers and subtract from 720, you would get 166. Did you get it? So the value is going to be 166. So which means that you can easily figure out what is y by not necessarily adding all these and then subtracting from 720 and so on. As you do that, you can just figure out what will be the number that will make this addition to become 720. And so the value of y is 166. Now, caution. Now, don't jump and choose this as your answer. That is not the correct answer. This is exactly a trap in many tests. So the question is to find out x and not this value. Okay. So you will find this. There's always one of the answer as one of the intermediate values that you produce, and then don't rush. And so x is going to be 180 minus 166, and therefore that's going to be how much? It's not 24, it should be 14 degrees. So it should be 14 degrees. Do you understand that? Okay. That's the correct answer. Did you get that? Very nice. So let's move on with the next question. And what is the measurement of one exterior angle in a regular, one more time, regular three-sided polygon, as we have been learning, is an equilateral triangle. So we know that all the interior angles each one of them should measure 60 degrees. And so the exterior should measure what? To get it? 120 degrees. So correct answer is this. Okay. I would like to go back and check this. Maybe if there's a mistake, I'll come back and fix it. All right. So let's move on to the next question. Okay, we have a few more questions to go. Are you following me all along? Okay. Okay. The question is now about diagonals. Question number 11. How many diagonals does a hexagon have? Didn't we do that? Yes. Let's say that we forgot it. So the number of diagonals, d is equal to n times n minus 3 divided by what? 2. Therefore, this is going to be 6 times 6 minus 3 divided by 2. I don't know why we are repeating this question. But anyway, 6 times 3 divided by 2, that's going to be 9 diagonals. And the answer is B9. Okay. Let's move on to the next question. Now, question number 12. What is the size of one interior angle of a regular decagon? You know, the prefix deca is represents the number 10. That's why you have the word like decade, 10, okay, or decimeter, that's 10, okay, everything is for, or decimal is 10, okay. So coming back, so therefore a regular decagon will have 10 sides, and like we learned before, there are multiple ways of solving this problem, but my preferred way is that going, if you forgot the formula. So if you forgot the formula, then we know that the sum of all the exterior angle is going to be 360, first class. And then there are 10 exterior angles, so I'm going to divide this by 10. So therefore, every exterior angle is going to be 36 degrees. And therefore, every interior angle is going to be 180 minus 36. And that is going to be 4. And then this, how much? 4? 144 degrees. So as you can see that, as the number of sides increase, the exterior angles become smaller and smaller, the interior angles become larger and larger. So we have 10 sides, and but the question is just to find one interior angle, and that's going to be 144. Did you understand this? Okay. You can also solve this by using formulas, if you remember the formula. Okay. And let's move on to the next question. A polygon has 44 diagonals. Wow. That should be a substantial number of sides. Okay. How many sides does it have? Well, the easiest way is to use the formula. And so we know that the number of diagonals is n times n minus 3, everything divided by 2. Now we know the number of diagonals as 44. Okay. And that should be equal to n times n minus 3 divided by 2. So now this becomes a quadratic equation. So we got to use our common sense to solve this problem. Now please do not fight with this. It's never a good idea to fight with a question and lose time. If let's say that you do not know how to solve this problem, because this is going to become like this. It's going to become nasty. It's going to be n squared. Let's n squared minus let's say 3n, everything divided by 2. And so if you know what you're talking about, this is going to become like something like, you multiply both sides by 2 to get 88 should be equal to n squared minus 3n, and so on and so forth. Okay, this is not worth, okay, if you do not know how to solve this. And so the best way to solve this will be go back to the answers and see which one is going to fit. If you have some reasonable knowledge on the number of diagonals, then it'll probably help. I'm going to begin with 10. Okay, let's say if let's say 10 is the number of the number of sides. Okay, so then d is going to be the number of diagonals are going to be 10 times 10 minus 3 is going to be 7 divided by 2. So that's going to be 5 times 7 is 35. Therefore, we have 44 diagonals. So therefore, it has to be more than 10 sides. And so the answer has to be 11. Did you understand that? That's how you have to be smart to solve problems like this, which is likely to take away a lot of your time. So it's not necessary for you to, unless your test is going to ask you to show your work. Most of the multiple choice question tests, which are going to be evaluated using a computer, your work is not going to be seen by anybody. So you need to be very smart and try to solve this problem in under a minute. Okay. As we speak about polygons, do you know what is the name for 11-sided polygon? Well, I didn't know that. So before I recorded this lesson, I Googled and then checked the name. And do you know what is that? It's called hendecagon. It's called hendecagon. I believe that the word hendeca in Greek would mean 11. So that's why it's called hendecagon. Nice, right? By the way, 11 is a very special number in math, and one of these days in one of the lessons, I'm going to teach you a nice technique to multiply any number by 11. It's very cool, okay? Now, by the way, 11 is also a very important number in world history. Do you know why? The World War I ended at the 11th hour of 11th day of 11th month in the year 1918. Did you know that? That's pretty cool, right? The World War I ended at the 11th hour on 11th day of the 11th month in 1918. Just remember this. Maybe in one of the interviews, if you can give this answer, you might get a good job, right? All right. Very good. Let's move on to the next question. I think, yes, we have a few more questions to go. Okay. Are you enjoying the class? Do not pause. Okay, let's keep going. It's not a very long class. Okay. Question number 14. Shapes A and B are regular polygons. Beautiful. So three-sided regular polygon is equilateral triangle, and six-sided polygon is hexagon. Okay. What is the value of x minus y? That's beautiful. So this is instantly, we know that the exterior angle, there are three exterior angles, and so that'll be 360 divided by 3, which is going to be 120. And y, in this case, there are 6 exterior angles, so 360 divided by 6, which is going to be 60. So therefore, x minus y is going to be 120 minus 60, which is going to be 60 degrees. This is an open-ended question, 60 degrees. That's the correct answer. I hope you got it. In one of the classes, eventually, we would be discussing how to grid-in these open-ended questions in tasks which use grid-in techniques, okay, methods. Let's move on to the next question. Now the life is getting, what can I say, challenging. Okay. Read this question and then pause the video. You can even draw the same diagram in your own notebook and try to solve this problem by yourself. Just one clue, this problem is not as difficult as you think. Okay, let me read the problem. In a regular polygon A, B, C, D, E, therefore this is five-sided, which is a pentagon. Diagonals AC and BD. AC is this and BD is this. Intersect at R here, okay. Find the measurement of angle ARD, this angle. Okay. Like I said, pause the video. Try to do it by yourself. And one more time, the clue is this, okay. Whenever you have to figure out the measurement of one angle, you ask this question: what else should I know? What else should I know to find out this? For example, in this case, there are two diagonals which are intersecting like this, and so you want to find out this, and if you find out this, it'll be the same as this because they are opposite angles, intersecting angles, correct? Okay, and so if I want to find out x, okay, x seems to be a part of a triangle. So if I know these two angles, I can figure out what is x. Okay, so therefore, finally, it all comes down to, do I know these two angles? Do you know? Okay. Are you trying? Pause the video. Now, I hope you got the answer, and you can play the video now. And so let me show you how to solve this problem. Now, I want to find out this angle first, angle, which is DBC, the angle DBC. Okay. Now, angle DBC is a part of this triangle. Can you see this? Angle part of the triangle DBC. And in that triangle, we know that this is a regular polygon. Therefore, this side should be equal to this side. Do you agree with that? So I'm trying to draw the triangle separately. These two sides are equal. Therefore, what kind of triangle is that? It's an isosceles triangle. Beautiful. And we also know that because this is a pentagon, okay, the sum of all the 5 interior angles is going to be 540, if you remember that. And then divide this by 5, that's going to be 108. So we know that this is 108. Which one? This is 108. Did you understand that? So therefore, these two angles have to measure the same. So if you take this away from 180, That's going to be 72. So each of them should measure 36 and 36. Cool, very good. So which would mean that this angle is 36, and the same way with the other triangle, this is also 36. Did you see that? So therefore this is 36, this is 36, and then going by this, the sum of the angles of a triangle is how much? Interior angle is 180. Therefore this has to be 108, and this has to be 108. So the correct answer is 100. Did you get it? If you got it, congratulations. And if you didn't get it, that's fine. You learned a technique, how to figure out. Let's do one more problem. Question number 16. Shapes A and B are regular polygons. So as we can see, this is 1, 2, 3, 4, 5, 6, 7, 8. So this is an octagon, and this is a pentagon, as you can see, which share one of their sides as a common side. This is a common side. Okay. What's the value of x? They would like us to find out what is this angle which is sandwiched between these two shapes. Pause the video again. Take your time. Do you want a clue? Okay, the clue is very simple. So to find out x, if you know this and this, the three angles, let me use another variable. Let's say this is A and this is B. So A plus B plus x should measure how much? Angles around a point is 360 degrees. So A is the interior angle of this regular octagon. B is the interior angle of this regular pentagon. Pause. You can figure out. There's no answer here. Oh, there's no answer here. So we got to figure out the answer by ourselves. Cool. Let's go ahead and solve the problem. So to find out what should be the value of A, so there are multiple ways of doing this. So one of the ways will be to spread them into, like in this case, quadrilateral. So there are 360 degrees, 3 quadrilaterals. So it's going to be 1080 degrees. Okay. And this has to be divided by 8. You could have done with an exterior angle. Just remember that also. Okay. So that's going to be how much? 1, 8, 2, 28, 3 8s are 24, and 4, 45. That'll be 135 degrees. So A is 135 degrees. B, because it's hexagon, if you remember this, that'll be 108 degrees. We solved it. So therefore, now going back to our method, so 135 plus 108 plus this value of x should add up to 360. So use the same technique as before. So 8 plus 5, 13, plus what number will make us 0? Maybe 7. 8 plus 5, 13, plus 7 is 20, carry is 2. 2 plus 3 is 5. 5 plus 1 will be 6. There is no carry. 1 plus 1, 2. 2 plus 1. So therefore, x is going to be 117 degrees. Did you understand that? Do you like this problem? Pretty easy problem. It might look very like scary, but it's pretty easy once you understand how to go about doing this. And finally, we'll take a challenge before we close this lesson. So far, so good, right? Very good. Let's read the challenge. As before, I recommend that you read the problem or even write down the problem in your notebook and pause the video and solve the problem by yourself. Come back and resume the video to see if you got it right. The center of circle O, is a circle here, coincides with vertex O of irregular polygon O, A, B, C, D, E, as shown in the diagram. Vertices A, B, C, D, and E measure so much. Okay. M is the midpoint of AO, the midpoint of this. which measure 24. So this is 24, and so this should be 12, and this should be 12. Therefore, one of the instant thing that we know is that the radius of the circle is 12. Okay. Find the area of the shaded part, which is the blue. Okay. See how the cursor color changes. I like it. Okay, so let's see. Now we know how to find the area of a full circle with a radius 12, which is the area of a circle is going to be pi r squared, right? Which is going to be, so in this case, pi times 12 times 12, which is 144 pi. But a part of the circle is gone. So, which would mean that for us, we need to figure out what is this angle. So because a circle is round 360 degrees. You understand that? So if, for example, if let's say you take away this part of the circle, which is 90 degrees, so the area of this rest of the circle is 3/4, because 1/4 is gone. Okay, do you understand what I'm trying to say? Same way, for example, let's say if you take a circle like this, and if let's say you take away this part of the circle, which let's say measures at the center 60 degrees, then therefore this is 5/6 of the circle, and this is 1/6 of the circle. Do you understand what I'm trying to say? Very good. So we're going to use the same technique. Therefore, we got to figure out what is the measurement of this this interior angle, which is here, right here. So one more time. So we got to add up. So therefore, that's pretty simple. So first of all, we should know what's that? The sum of the interior angles of this shape. So that's very easy. So we can make this into two quadrilateral like this, which will be 360 plus 360, I be 720. So I'm going to erase and make some space. So all this plus, I'm going to call this as, let's say, x. All this angles plus x should make 720, back to the same technique. So I have 135, and then I have 95. We got to do this very fast. 155, and then 90, and then 125, and then the x comes here, correct? Okay, is it right? 135, 95, 155, 90, and 125. So let's add up this. So 4 5s are 20 plus what number is 0? 0. Okay. So carries 2. 2 plus 3 is 5. 5 plus 9 is 14. 14 plus 5, 19 plus 9, 28 plus 2, 30 plus 2, and so 32. So the carry is 3. 3 plus 3, 6 plus 1. So therefore it should be 120. That's very cool. So we know that therefore this is 1/3 of the circle is gone. So because 120 divided by 360 is 1/3 of the circle is gone. So therefore the total area is so much. So therefore if the area divided by 3 is going to be 144 pi divided by 3, which is what? 48. 3 48s are 144, right? Pi. So 48 pi is the area of 1/3 of the circle. So we need to find out the area of the shaded part, which is 2/3 of the circle. Therefore, this is 1/3 is 48 pi, and therefore 2/3 of the area of the circle is going to be 48 pi times 2, which will be 96 pi. That's the correct answer. Did you get it? Very cool. Congratulations if you got it. If you didn't get it, go back and rewind the video and understand how exactly it goes. And if you have any questions, definitely go to our website, prepmate.com /contact, and then submit your questions. And if you like this, there are a couple of more videos I understand in our website for you to see. And then come and register to take online classroom. There are going to be so many such classes, and I'm sure not only in math but also in reading, revising, and editing. All right. So good to see you guys, and all the very best.